Hello everyone, this is Notes for 2C in Unit 5. And this page right here, this is where the video is going to go. So you're in Unit 5, Notes for 2C. So we just learned about exponents. We have a base to a power. So for example, if you look right here, that's 5 to the 4th power. And 5 to the 4th power means 5 times 5 times 5 times 5. Okay? So this is just a reminder of what we learned last time. Today we're going to learn about two rules for exponents. The first one is called the product rule. So the product rule says, so this is the product rule, it says if you have some base to a power, x to the n, times that same base to another power, x to the m, it equals x to the n plus m. So what do? You add your exponents. So if you're multiplying the bases, you add the exponents. Why? How does that work? Well, if you look at our example over here off to the right, notice that it says 5 to the 4th times 5 to the 3rd. Well, 5 to the 4th is 5 times 5 times 5 times 5. Times 5 to the 3rd is 5 times 5 times 5. Now, if you count, you have a bunch of 5s that you're multiplying. How many? 1, 2, 3, 4, 5, 6, 7. So it equals 5 to the 7th. Now let's go back to the original problem right here. So it equals 5 to the 4 plus 3, which is 5 to the 7th. So instead of writing it all out like that, you don't have to do that if you can remember that you add your exponents. Now I need you to be patient with me because at the beginning I'm requiring that you write it out. And there is a really big reason why I'm requiring that. Because if you don't write it out, you're not going to remember what you're supposed to do. There are 4 rules for exponents, so there's a lot. And you have to be able to remember which rule goes with which one. So we're on number 1 right here, 6 to the 4th times 6 to the 5th. So in the work area, we're going to write 6 to the 4th power. And remember that that's 6 times 6 times 6 times 6. And then times 6 to the 5th power, which is 6 times 6 times 6 times 6 times 6. Okay, now if we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 6s. So that is 6 to the 9th power. Now, look at what we wrote up above it. We wrote 6 to the 4 times 6 to the 5. That equals 6 to the 4 plus 5, which is 6 to the 9th. So again, notice that we get the same answer. Now we go type 6 to the 9th right there. Now make sure you have the work. That is super, super important. You need to show the work. If you don't show the work, you're not going to remember why you're doing what you're doing. Okay, now we're going to switch colors, and we're going to go to number 2, 3.1 to the 3rd. So we have 3.1 to the 3rd, which is 3.1 times 3.1 times 3.1. Okay, times 3.1 to the 2nd power, which is 3.1 times 3.1. Okay, now if we count them, 1, 2, 3, 4, 5. So that's 3.1 to the 5th. Now look up above, and it equals 3.1 to the 3 plus 2, which equals 3.1 to the 5th. So now we go and we type 3.1 to the 5th. Okay, now number 3, we're not going to write it all out. So on number 3, we're not going to write it all out this time. Number 3 is 2/5 to the 6th times 2/5 to the 8th. So now we've done it several times where we wrote it all out and we counted them. Well, now we remember that it's 2/5 to the 6 plus 8, which is 2/5 to the 14th. So then we go type 2/5 to the 14th. Okay, now the very last one I want you to notice is a variable, not a number. It's okay. We're allowed to do that. So we have m to the 2nd times m to the 4th, which is going to equal m to the 2 plus 4, which is going to equal m to the 6th. M to the 6th. So if you are multiplying your bases, your base is, on the number 1, your base is 6. So if you have 6 to a power times 6 to a power, you add your exponents together, because if you write it all out, if you count them all up, that's how many 6s you have. Okay? Make sure you have all of the work in the work area before you submit. So the first one was, we type 6, which is our base, then we type our exponent button, and we type our 9. Then we type in the second one 3.1, which is our base, then the exponent button, and then 5. Then on the third one, remember to do a fraction, you're going to hit the parenthesis, then the fraction, then you're going to type the numerator, which is 2, the denominator, which is 5, then put your cursor on the outside of the parenthesis, type your exponent button, and type 14. Then on the last one, m, which is your base, your exponent button, and 6. And then we submit. Number 2. So number 2 is the second rule of exponents that we're going to learn. So let's do a refresher again for just a moment. So if you look at what we have right here, we have 7 to the 6th power. Remember that 7 is the base and 6 is the exponent. And remember, the exponent is the one that's like floating up above it on the right side. So 7 to the 6th power. Okay? Okay, now the quotient rule says if you're dividing your bases, so if you have some base x to the nth power divided by that same base x to the mth power, it equals x to the n minus m. So it tells you that you're going to subtract the exponents. So when you're multiplying the bases, you add the exponents. So you got to think, multiply and add, they kind of go together. And then if you're dividing the bases, you subtract the exponents. And dividing and subtracting kind of go together. So our example for the y, why does this work? We have 7 to the 6th power divided by 7 to the 2nd power. So we have, on the numerator, we have 7 times 7 times 7 times 7 times 7 times 7. So we have 6 sevens divided by 7 times 7. Okay, now, do you remember that 7 over 7 reduces down to 1? 7 over 7 reduces down to 1. So what I have left is 7 times 7 times 7 times 7 in the numerator times 1 times 1. Well, do you remember that anything times 1 is that thing? So if we have 7 times 7 times 7 times 7 times 1 times 1, what we really have is 7 times 7 times 7 times 7, or 7 to the 4th power over 1. Well, we don't need the 1, right? 7 to the 4th power over 1 is the same as 7 to the 4th power. Now, let's look back up at what we had here. It's 7 to the 6 minus 2, which is 7 to the 4th. Okay? So that's the quotient rule. If you're dividing your bases, you subtract your exponents. Okay, again, just like we did on the first problem, be patient with me because we're going to show work on the first couple of problems. Okay, I need to make my screen just a little bit smaller so I have enough room to write. Okay, so the first one is 3 to the 7th over 3 to the 3rd. So we have 3 to the 7th over 3 to the 3rd. So that's going to be 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5, times 3 times 3 over 3 times 3 times 3. Okay, well, 3 over 3 reduces down to 1. 3 over 3 reduces down to 1. 3 over 3 reduces down to 1. So now if I count, do you notice I just have a 1 in the denominator, and I have 4 3's in the numerator. So I have 3 to the 4th over 1, which is 3 to the 4th. Now let's go back to what we had at the beginning. So 3 to the 7th over 3 to the 3rd equals 3 to the 7 minus 3, which is 3 to the 4th. Now look, didn't I get the same answer both times? So everybody make sure you have all that work written down. Now on this one, we're only going to write it all out just the one time. So when we go to the second problem, we have 0.22 to the 7th. So we have 0.22 to the 7th over 0.22 to the 2nd. So that's going to equal 0.22 to the 7 minus 2, which is 0.22 to the 5th. So then we're going to come over here and we're going to type 0.22 to the 5th. Not 4th. I said 5 and I wrote 4. Okay, number 3. Number 3, we have 4/5 to the 6th over 4/5 to the 2nd. So 4/5. Oh, I do not have enough room right there. Hold on. I'm going to do it over here. Okay, we have 4/5 to the 6th over 4/5 to the 2nd, which is going to equal 4/5 to the 6 minus 2, which is 4/5 to the 4th. So then we come over here and we type 4/5 to the 4th. Okay, and then the last one, we're going to show our work on the last one. So we have c to the 6th over c to the 3rd. C to the 6th over c to the 3rd. So that's c times c times c times c times c times c over c times c times c. Okay, just like numbers, if you have c over c, that reduces down to 1. C over c reduces to 1. C over c reduces to 1. So what do we end up with? In the numerator, we have c times c times c, which is c to the 3rd. In the denominator, we just have 1. So it's c to the 3rd. Okay, now let's go back to what we had at the very beginning. So remember that we had c to the 6th over c to the 3rd, which is going to equal c to the 6 minus 3, which is going to equal c to the 3rd. So it's the same thing no matter, even if it's a variable, it's exactly the same thing. Now, make sure you have all of the work written down before you submit. So for number 1, our base is 3. And then we hit the exponent button, and it's 4. Number 2, we have 0.22, and then we put our cursor outside the parenthesis, and we hit our exponent button, and it's 5. Then on number 3, remember, if it's a fraction, you're going to hit the parenthesis, and then the fraction, and then you're going to type the numerator, which is 4, and the denominator, which is 5, and then put your cursor outside the parenthesis, hit the exponent button, and it was 4. And then on this one, we have C, and then the exponent button, and then 3. And then we submit. Number 3. Okay, so on number 3, all of these 3 problems are using the product rule, the first one that we learned. So what we're going to do is in the work area, we're going to write the product rule so that we can use it. Okay, so everybody, we're going to write product rule. And the product rule is X. I'm going to use an example instead of the N and the M. So X to the second times X to the third is going to equal X to the 2 plus 3, which is X to the 5. I think sometimes having an example instead of just the variables makes it easier for students. Okay, now we're going to look at number 1, which is 11 to the 7th times 11 to the 6th. Now, if you look, notice we did X to the 2 plus 3, so we're going to do 11 to the 7 plus 6, which is 11 to the 13th. So then we type 11 to the 13th in the answer box. Okay, now, number 2, this one's a little tricky. So if you look at it, it's 11 to the y, 11 to the y, times 11 to the 7th, equals, okay, 11 to the y plus 7, and it equals 11 to the 18. Wow, okay, now what? What do we do here? Well, we're supposed to figure out what y is. So if you look, your exponent is y plus 7 and your exponent is 18, and we know that they have to be equal because of this property. So we're going to go over to the left side and we're going to write down y plus 7 equals 18. Now we just solve. We've been solving equations since August. We can do this part. So what's happening to the y? It's being added by 7. So we're going to minus 7 because we have to do the opposite. So we have y, 7 minus 7 is 0, equals 18 minus 7 is 11. So 11 to the 11th times 11 to the 7th equals 11 to the 18th. So I'm going to write that down so you can see. 11 to the 11th times 11 to the 7th equals 11 to the 11 plus 7, which equals 11 to the 18th. And see how it works now? Okay, now we're going to do number 3. 11 to the 6th times 11 to the p equals 11 to the 6 plus p, which equals 11 to the 12th. Now remember, we know that the 6 plus p has to equal 12. That's what we've learned, right? So we go over on the left and we write 6 plus p equals 12. Okay, now we can totally do this. What's happening to the p? It's being added by 6. How do we do the inverse of add? We subtract. Minus 6 minus 6. 6 minus 6 is 0, and we get p equals 12 minus 6, which is 6. Make sure you have all of the work in the work area before you submit. So here our x was 13. Okay, here our x was 11. And here our x was 6. Our p, sorry. Wait a minute, it's not even x. Z was 13, y was 11, and p was 6. And then we submit. Number 4. Okay, number 4 is using the quotient rule. So we're going to write out the quotient rule. So the quotient rule x to the third divided by x to the second equals x to the 3 minus 2 which equals x to the first. Okay, now we're going to use that to do number 1, 2, and 3. So number 1, 11 to the 9th over 11 to the 6th is going to equal 11 to the 9 minus 6, which is 11 to the 3rd. So Q is 3. Number 2, 11 to the y over 11 to the 6th equals 11 to the y minus 6, which equals 11 to the 9th. Okay, now we know that y minus 6 has to equal 9. So we go over off to the left and we go y minus 6 equals 9. Okay, what's happening to the y? It's being subtracted by 6. So we have to add 6 to undo that. So we get y, negative 6 plus 6 is 0, equals 15. So y is 15. Okay, and then the last one, we have 11 to the 12th over 11 to the r equals 11 to the 12 minus r, which equals 11 to the 9th. So we know that 12 minus r has to equal 9. 12 minus r equals 9. Okay, now this one is a little bit more complicated because what is happening to the r? Well, there's an invisible 1 right there. The r is being multiplied by negative 1, and then it's being added by 12. So this one's going to take 2 steps. Remember, we have to undo the addition first. So if it's being added by 12, what's the inverse of add? Minus. So we're going to minus 12 from both sides. 12 minus 12 is 0. So we have negative 1r equals 9 take away 12. Okay, so that's the same as 9 plus negative 12. So if I have 9 positives and 12 negatives, remember that I have to subtract because I have both positives and negatives. 12 minus 9 is 3. The 12 is the bigger number and it's negative, so the 3 is negative. Now, what's happening to the r? It's being multiplied by negative 1, so I have to do the inverse and divide by negative 1, and I get negative 1r divided by negative 1 is r, equals negative 3 divided by negative 1, which is 3. So r equals 3. Make sure you have all the work written down before you submit. So for the first one, the q equaled 3. For the second one, the y equaled 15. And for the third one, the r was 3. And then we submit. And now you're ready to go do homework 2C in Unit 5. Have an awesome day.